So there's an algebraic way of making an inverse function. Okay, so they give you function notation to begin with. So if they say f of x equals x squared, they're saying this is a function. All right. So f of x equals x squared. If I pick any value of x, don't pick a number. 3. 3 squared equals 9, right? So if I don't write this down, but if I just started making a set of ordered pairs here, 3 leads to 9. Does it lead to anything else? So an input of 3, 3 squared is 9, gives me an output of 9 based on this equation. Y is basically what f of x is. If x equals, let's say, Daniel, pick another number, 2. 2 squared equals 4. Does it equal anything else? No. So each x I'm putting in is getting me one y out, right? So it's not like I'm putting in 7 and all of a sudden I get 49 and something else, I just get 49. Every value of x that goes in leads to, or evaluates to, exactly one y out. So this is functional notation. It is a function. All right. So they're going to start you off a lot of times with a function. But here's what I'd like you to do. No matter what they call this thing, rewrite it as y equals x squared. Change f of x into the letter y. Okay, so if they're going to give you an equation, I want an xy equation. If they give you a functional notation, f of x, g of x, whatever, call that y. In order to make the inverse relation on the last problem, I took the x's and y's and swapped them, right? To invert an equation, you're going to swap the letters. X becomes y, y becomes x. So again, that's how you make the inverse function. That's just how you do it. So basically, the first step in these problems, when it says write the inverse relation, step 1, write the answer. This is the answer. Step 2, make it say y equals. So if x equals y squared, how do I find y? Take the square root of x, right? But remember, if y squared equals a number, then y equals plus or minus the square root of that number, right? Not just the square root, but plus or minus the square root. When we introduce the square root symbol on the problem, it's an even power, we need to put a plus or minus. Because if y is 5, 5 squared is 25. If y is negative 5, negative 5 squared is 25. So the square root of 25 is both 5 and negative 5, right? So plus or minus. All right. And then we get to this point where the inverse relation is y equals. So y equals plus or minus the square root of x is the inverse relation. Now, once we get the algebraic inverse relation, so we've created this equation that's the inverse relation, now we must also determine if this thing's a function. If it is, we have a different way of writing the notation. If it isn't, then we don't. All right, so is the inverse relation a function? Again, the question you're asking yourself is, if I put a value of x in, will I get exactly one value of y out? If I do, yes. If I don't, no. All right, so for example, based on real numbers, x must be 0 or bigger, right? We can't let x be a negative number. That doesn't matter, though. It doesn't matter, we can't let x be a negative number. It only matters if I put something in for x, I'm going to get exactly one number out for y. So, if I put in the number 0 in, what's the square root of 0? What's the difference between positive 0 and negative 0? There's nothing different, right? So 0 leads to 0. One input value gets me one output value. So for 0 specifically, it's following the rules, right? What's the next number up from 0? 1. What's the square root of 1? 1. Is plus 1 the same as minus 1? No. So 1, x1 leads me to both positive 1 and negative 1. Notice, just like the last problem on the inverse, this value of x gets me two different values of y. So this is not a function.
So how did you get 1, 1, and then 1 negative?
I just pick numbers. I'm inventing values of x. I have an equation here relating x and y, right? So you pick the x as anything you want to be. These are independent. and y is dependent, you pick anything you want for x, but it has to follow the rules, so the domain of this would be greater than or equal to 0 because the square roots and negatives are imaginary. So x is 0, 1, 2, anything you want x to be. You're just asking yourself, if I put something in for x, do I get exactly one thing out for y? Some cases yes, but not all cases. Any other number I picked, if I picked x equals 4, I'm picking 4 because the square root of 4 is 2. Square root of 2 is not as easy as square root of 4, right? Square root of 4 is 2. Well, I get positive 2 and negative 2. Once again, I have exactly one value of x leading to multiple values of y. One input leading to two outputs. So this is not a function. All right? So, if you happen to get a function, suppose you do the same problem, you make an inverse relation, and you figure this out, and you make your little chart here, and you see every x you put in leads to exactly one y. That happens sometimes. If that should happen, if it is a function, the right way to write the answer is this. Whatever. This would be the answer right here, whatever this is. So you change y into f minus 1x. This is read f inverse of x. If it's a function, that's how you write it. If it's not a function, don't write it that way because this is functional notation. It's only used for functions. If it's not a function, stop here. If this said it is a function, yes, it's a function, then you would write f inverse x equals and then whatever the answer was. All right, so that happens in some of your problems. There's not a whole lot of assignment problems, but I think we got 6. So tomorrow's assignment's much longer because you're going to learn a little bit more tomorrow that you need to know to be able to do most of the problems out of the book. But for right now, the 6 problems I gave you involve what I talked about today. Again, just considering input and output, that's what you're looking at. X is the input, Y is the output. When you invert, you're swapping those. The relation you're given might be a function, the inverse might not, or vice versa. So it's just a matter of investigating each one individually to figure that out.